As we played with position versus time diagram, we can do the same thing with velocity versus time diagram. So instead of plotting x, I'm going to plot v in meters per second versus t in time, or in seconds. So let's see what type of function we're going to be facing. In this class, we will always be dealing with constant acceleration, which means that we're being reduced to straight line, which refers to cases where the magnitude of the acceleration doesn't change as a function of time. So this obviously is possible. This is possible. This is not something we're going to encounter. So from point A to point B, we know that the slope of a velocity versus time diagram tells us something about the acceleration. In this particular case, the slope is positive, and it's the same for all points between A and B. Therefore, the acceleration is constant, and we can extract its particular magnitude by calculating the slope, which is yb minus ya divided by xb minus xa. We get its magnitude, and we'll end up with a positive number, which tells us that we're accelerating. Again, remember that the sign of the acceleration doesn't tell us anything about the direction of the motion. We're only able to tell whether we are accelerating or decelerating. That is, in this particular case, we start from velocity of 0, then velocity of 1, then velocity of 2, then velocity of 3. So we're increasing our velocity at a constant rate every second in this particular case. Now from B to C, our velocity is at 3 meters per second, then 3 meters per second, then 3 meters per second, and 3 meters per second. Therefore, A is still constant and equal to 0. We're not accelerating nor decelerating. We're cruising at constant velocity or constant speed. And then from C to A, we have a straight line. Therefore, we know that the acceleration is constant. We obtain its magnitude. We will obtain a negative slope. Therefore, we know that we're decelerating. That is, we're going from velocity of 3 meters per second to a velocity of 2 meters per second at some time later, then 1 meters per second, and then we're gonna stop the vehicle, or the particle is stopping, because at final time the velocity is 0. So we went from 0 velocity to 3 meters per second, then we stay at 3 meters per second for a certain amount of time, this time, and then we reduce our velocity again and stopped after this amount of time. Acceleration, constant velocity, deceleration.